All right, I picked up this broken Zendrive off eBay. The seller said that it would pass signal in bypass, which probably means the switch is okay, but when you engage the pedal, no sound through the pedal. I did plug it into an amplifier and confirm that was the case. Works fine in bypass, no signal when the pedal's turned on. The LED does work. As far as the pedal exterior here, everything looks fine. Got our standard Zendrive volume gain, tone, and voice. Input and output jacks are side mounted. 9-volt DC jack, PCB mounted on the side here. I'm not super familiar with the Zendrives, but I know the original ones were made by Alfonso Hermida, and I think in 2013 or so, he sold the rights to Love Pedal, who continued making them under his guidance or advisement. So now all the current Zendrives that are being made by Love Pedal, and that is what this version is. This is a Love Pedal version. If you want to see what the original Zendrives more or less look like, I did a teardown video of the Nosferatu, which was sort of the predecessor to the Zendrive, and they look very similar inside because they're essentially the same pedal. So let's go ahead and crack open the Zendrive here and we'll see what we can see. All right, so unfortunately this pedal is assembled in a way that makes it hard to take apart. Basically, the 1/4-inch jacks are dropped into the enclosure and then the PCB dropped on top of them and then they're soldered into place, effectively locking the PCB in. You can't pull it out because the sort of the throat or the outer sleeve of the 1/4-inch jack is locked into the enclosure by poking through on either side, and so they're keeping you from pulling up on the PCB. So I'm gonna have to desolder the 1/4-inch jacks in order to get the PCB out of the pedal. All right, well, that went about as bad as it could have. So unfortunately, the combination of plated through holes and lead-free solder and really small through holes defeated me and made it basically impossible to get these out with a manual solder sucker. I should have trusted my gut and just waited. The right tool here would have been a vacuum desoldering gun, but I do not have one of those, and instead of being patient, I tried to just push it with the manual solder sucker and ended up having to force it like you saw, which never would have worked. So I should have been patient and got the right tool, but I chose to push ahead, and unfortunately, I lost multiple pads on the PCB here on both sides. So this PCB is pretty much shot. It would be at least too unreliable, and at worst, it just wouldn't work at all. So this PCB is going in the trash, unfortunately. However, we can look on the bright side. We do still have components here that can be salvaged. We, of course, have the potentiometers, which I should be able to get those out at least. The op amp here, which is down here and is socketed conveniently. It is a NN5532, or sorry, it's a NE5532, Texas Instruments. There are a couple of what should be MOSFETs in here, TO92 packages. They are painted silver over the top, so I'm going to try and pull those out, and we'll take some alcohol to it, see if it's just paint or if it's something more than that. Got the clipping diodes down in there. And then the rest is just basic carbon film resistors and other simple components, nothing crazy there. Beyond this, might try making a new PCB for the enclosure here, which is still fine, and rebuilding the pedal with a new PCB, and unfortunately scrapping this one. So let's go ahead and try to get the other components out, and then we'll see what we're left with. All right, so here's one of those transistors. You can see the top is covered over to hide what part it is. I'm gonna try just some isopropyl alcohol, see if that gives us anything. Seeing it now, I don't think they're painted, I think they're sanded. That's just sanded off. Okay. So isopropyl alcohol is not gonna help us because they're not painted, they're just sanded down. All right, we can also test the transistors with the DCA75. So we're expecting these to be N-channel MOSFETs. That is the, I guess you could say, claim to fame of the Zendrive design is using the body diode that's built into small signal MOSFETs like this as a clipping diode. All right, so that comes up N-channel MOSFET, as you'd expect. VGS on of 1.6 volts or so. VGS off is 1 volt and transconductance of 28.5 or so. Let's try the other transistor. Second transistor, N-channel MOSFET, VGS on 1.6 volts, VGS off 1.1 or so, and transconductance 29.2. So the values of the transistors, as we saw, is obscured, but usually the replacement part number is a 2N7000, which I happen to have a small batch of. Let's try some of these 2N7000 and see if anything pops up. Here's one 2N7000, not sure the manufacturer on this one. And channel MOSFET, VGS on 1.56, VGS off about 1 volt. Transconductance a little higher, 35 milliamps per volt. Let's try another one here. Here's another 2N7000. VGS on a little higher, 1.96, about 2 volts. VGS off, 1.4 volts. Transconductance, 34 milliamps per volt. Another option for the Zendrive is a BS170. It's another N-channel MOSFET. I have a few more of those. Let's just grab. There's a Fairchild one and a Motorola. So this is a Motorola BS170. N-channel MOSFET. VGS on 2.8 volts, so significantly higher there. VGS off, 1.9 volts. Transconductance 18. So I think BS170 or 2N7000 could replace whatever the specific part number is in the Zendrive, assuming it's something else. But it's probably one of those. All right, so here's what we're left with. We got the 4 potentiometers, we got the op-amp NE5532, we got the 2 probably BS170 MOSFETs, and the salvage, or I should say, to be trashed PCB. My intention, I'm going to try and make a PCB that matches the footprint of this. That way we'll be able to drop the new PCB right into the enclosure, and it'll be essentially the same, hopefully sounding the same, using the original components. So I'm going to go over and start designing now, and hopefully we get something that'll work. All right, so it's been a few weeks for me, but just a couple seconds for you. Got the replacement PCB here that I designed. I tried to stay pretty true to the original design from Love Tone. However, obviously there's some major differences. Namely, the bottom half of the entire PCB is gone. I have opted for going with off-board components, partially because I don't have PCB mounted 1/4 inch jacks and foot switch, GC jack, grounding spring, all that, but also because going with off-board components will solve the problem that initially caused this, which is using those PCB mounted 1/4 inch jacks makes it really hard to remove the PCB from the enclosure. So by using off-board components that are on wires, I'm not going to have that problem. It also solves a couple other issues, which is that the 1/4 inch jacks I can use now, this is the Switchcraft 112BX. These have non-insulated collars here, which means they're going to ground to the enclosure and I don't need a separate grounding spring. I can also use a standard 2.1 millimeter off-board DC jack, Kobicon external nut jack. I can use one of these nice Gorva foot switches that have a really soft actuation pressure and have significantly improved lifespan. So I can use one of these. And then on top of that, we're still going to use all the original components we pulled from the original pedal, the pots, knobs, of course, the extra components, the film caps, the op-amp, got the MOSFETs, the clipping diodes, and of course even the LED. All right, I pretty much got the pedal assembled here. I did find one error on the PCB. You can see right there in the corner, I had to run a little jumper from one of the input pad ground up to a ground on some component. I forgot to connect the ground pad that I put into the board to the actual ground plane. Just a mistake. Growing pains designing PCBs, I guess, but a good lesson for me personally, and nothing a little jumper can't fix. So now, as far as the op amp, it was obviously be a little bit easier if I had put that in prior to the potentiometers, but the original op amp I believe to be working. It is a Texas Instruments NE5532, which is a great op amp, nothing wrong with it. However, it's currently believed that the original op amp, although they were sanded down on the original Zendrives, the current belief is that the op amp was a Analog Devices AD712, and I happen to have a small handful of those. So I'm going to throw a 712 in there. Is it going to make a big difference? Like I've said in previous videos, I don't think so. I don't think op amps make basically any difference at all. Even if it did make a difference, the idea that you could reliably pick out that change that's down to specifically the op amp is dubious, I guess. But we're going to throw it in there because it's thought to be the original. I have some on hand, so why not? I also did sockets for the clipping diodes and for the MOSFETs just in case someone wanted to experiment, or if one of them failed. MOSFETs are finicky devices, so that's not completely out of the question.